Chapter 2, Unit Exam Review, number 5. Find the domain of each function. Now you're looking for not having a negative underneath the square root, and you do not want division by 0. So those are the two things we're looking for to restrict the domain. The first one, f of x equals 3x squared plus 2x, has neither of those. It doesn't have a radical and it doesn't have a fraction. So therefore, the domain is from negative infinity to infinity. There are no restrictions. The next one, we do have a radical. We have to keep 5 minus x underneath the radical greater than or equal to 0. So if I have negative x greater than or equal to negative 5, multiplying or dividing by a negative reverses the inequality, and I have x is less than or equal to 5. Written here as an interval, it's from negative infinity to 5 inclusive. We have to keep what's underneath the radical in the interval between negative infinity and positive and 5, inclusive of 5. The next one, we have a denominator, and we have to make sure that the denominator does not equal 0. So this is factorable. It's factorable into x and x, and we have 4 and 2. We're making it a positive 4 and a negative 2, so we get a positive 2x in the middle term and a negative 8 as the last term. Setting the factors equal to 0, we get x is equal to negative 4 from the first factor, x is equal to positive 2 for the second. That means that those numbers cannot be values that are included in the domain. So we have from negative infinity up to negative 4, or we have from 4 up negative 4 up to 2, or from 2 to infinity. In this way, we've excluded the values of negative 4, and we've excluded the values of positive 2. Number 6, we're adding the two functions f of x and g of x. So we have x squared in the f function, we have x squared in the g function. X squared plus x squared is 2x squared. The x term, we only have 2x from the f function, and we have a negative 1 and a positive 5 is positive 4 from the g function. 2x squared plus 2x plus 4. There are no restrictions because we don't have a square root, and we also don't have a fraction where you have to worry about division by 0. The next one, we have the f divided by g, so f of x is in the numerator and g of x is in the denominator. Now when I look at putting in values, x squared, regardless of whether I put in a positive, negative, or 0, if I add 5, I'm not going to get division by 0 because I can't get x squared equal to a negative 5. Therefore, the domain is from negative infinity to infinity also. F of g of x. This can also be written as f of g of x this way, which means that the g function goes into the f function. So we're taking x squared, and in place of x we're putting the g function, x squared plus 5, and squaring it, plus 2 times x squared plus 5 minus 1. Now if I'm taking and squaring x squared plus 5 times x squared plus 5, the first terms of each give me x to the 4th. Then a 5x squared and 5x squared is 10x squared. And then 5 times 5 is 25. Distributing the 2, I get 2x squared plus 10 minus 1. Simplifying, x to the 4th. 10x squared and 2x squared is 12x squared. And 25 plus 10 is 35, minus 1 is 34. Again, there are no square roots, there is no fraction here, so our domain is from negative infinity to infinity.